Now that we've discussed how PathTrace works and how it differs from a standard traceroute, let's test it in the sandbox. To better understand how PathTrace works, let's explore the run pathtrace.py script. I kept this script especially simple and didn't include JSON or OS. We'll process the JSON outputs in memory, then write human-readable text to the console. Let's dive into the main function first. We'll continue to use the DevNet reservable sandbox via our standard SDK constructor. Then, we need to define the specifications for our path trace. Probably the two most important keys in this dictionary are source IP and dest IP. This identifies the direction of the trace, and these specific addresses represent leaf 1 and leaf 2 within the sandbox network. There are optional inclusions if you want to collect extra details. In our case, we've enabled all three, and I've included reference JSON files in the data ref directory if you want to explore their structures. These last two Boolean options are used for dashboard-based traces where you may want periodic refreshes. In our case, we don't care about these options. To start the path trace, issue an HTTP post request to the flow analysis resource and include the dictionary we just reviewed as the HTTP body. You can uncomment this debugging line to see what the output looks like, and here's an example of the JSON structure. These requests are asynchronous operations, so let's wait for the task to complete before continuing. Once complete, we'll end up with JSON data that looks like this. A good sanity check is to ensure that the progress value equals the flow analysis ID. If it doesn't, there is some internal DNA center error that is not mapping asynchronous requests and responses together correctly. It's unlikely this would ever fail, but extra error checking never hurts. To collect the final results, let's issue a GET request to the flow analysis resource, this time appending our flow analysis ID we collected earlier. Here's what the output looks like, and it is very detailed indeed. I'm sure you have many ideas on how you'd consume such useful information in your own networks, but let's explore a simple display. First, let's grab the flow data to make indexing a bit easier. Then, I'll print a summary statement that indicates the direction of the flow from source to destination IP. The number of hops between these two IPs may vary, so let's use a for loop with an enumeration counter to measure the distance. For each network element in the path trace, let's print the hop number and the name of the device at each hop. Again, there is a ton of extra information I'm not displaying for simplicity, but I think you get the idea. Before running the script, I'll clear the screen. Let's run this path trace, which you should be able to replicate easily if you have a DevNet Sandbox reservation. The first line of output just summarizes the source and destination IPs and indicates directionality with an arrow. Then, the for loop in the script processes each hop in series, starting at leaf 1, transiting spine 1 in between, and ending on leaf 2. Again, be sure to explore JSON files in the data ref directory when writing your own scripts. Let's wrap up the module in the next clip.